This week, we're going to start working with elasticities of demand. To understand how they fit in, let's review what we've done so far. We started out by modeling the impacts of a policy using flowchart diagrams, which are a convenient way to begin to get a handle on how one thing leads to another. Then, for impacts that land in markets for traded goods, we've used supply and demand diagrams to identify areas that we think of as representing increases or decreases in social surplus. The next thing we need to do is to put actual dollar figures on those areas. And to do this, we're going to make use of real-world estimates of elasticities of demand for the goods we're analyzing, which we will typically find in existing literature. I'm going to start out by talking about what demand elasticities are used for, and then explain the math of how we incorporate estimates of demand elasticity into our linear demand model. I'll then explain how to do the actual computations, and finish with a few thoughts about when you can trust an elasticity estimate, either one that you've come up with yourself, or more likely, one that you've gotten from somebody else. So, what are demand elasticities used for? Well, two things. First, prediction of impacts, by which I mean predicting how many units of a good will either start being produced and consumed that weren't before, or stop being produced and consumed that were before, and then monetizing those impacts, that is to say, coming up with estimates of increases or decreases in consumer surplus. Sometimes we will also include estimates of increases or decreases of producer surplus, but primarily we'll be focusing on the consumer side. So, let's talk about prediction. Suppose we have a policy that we believe is going to increase the price of a good from some initial level, which we'll simply call P0, to some new higher level, which we'll call P1. Now, you already know that we're going to predict a decrease in the quantity of this good that is produced and consumed from Q0 to Q1. We'll call that delta Q. In order to determine how big that will be, we need to know first the size of the price change and then also the slope of the demand curve. So we're going to have to come up with an actual real estimate of that slope. And that's what we're going to use the elasticity for. Similarly, we could have the same policy, an increase in price from P0 to P1, and ask not just about how many units of the good will be affected, but indeed what will be the value to society, in this case cost, imposed by the policy as a result of those units no longer being produced and consumed. The answer will be that it'll be a combination of two areas on the diagram. We'll call this one Area 1 and this one Area 2. The change in consumer surplus is the sum of both of those areas. That is the amount of consumer surplus that is being lost. Meanwhile, in many cases, what we'll want to know is simply the deadweight loss, because in many cases, this portion of the loss of consumer surplus will be a transfer, either to taxpayers through tax revenue, or possibly to producers through an increase in producer surplus. The part we will care about is this additional triangle, which is pure loss to society, and that is just Area 2. So the question is, how do we compute those areas? And again, what we'll need to know is the size of the price change and, of course, something about the slope of the demand curve. I'll show you how we use elasticities of demand to answer those questions in the next clip.